Today, I am going to discuss how to solve an inventory problem with the help of EOQ model, that means economic order quantity model. I am reading the problem first, and it is also given in your video. The problem is Novelty Limited carries a wide assortment of items for its customers. One item in particular is very popular. Desires of keeping its inventory under control. A decision is taken, no order, only the optimal economic ordering quantity for this item. Okay, you have the following information. What informations are given in the problem that I am writing first? First, annual demand. Annual demand is given. Annual demand is given. Say D is equal to 1,60,000 units. This is the demand. Okay. And ordering cost per order. This is given in your problem. Ordering cost per order. So this is CO is equal to rupees 50. It is also given. And carrying cost or holding cost, same thing. Carrying cost per unit of time. In this case, time is 1 year. Per unit of time, say this is represented by CH is equal to rupees 1. What you have to find out? You have to find out the economic ordering quantity, means the best ordering quantity, so that the total cost for the overall period is minimum. So before going to solve this problem, I want to discuss in brief the EOQ model. Though I have already done a separate video, I will keep the link of that video. To get the detailed idea, you see that video. Okay. Now, the basic assumption of this model is demand is known. Demand is deterministic, not probabilistic. That means you know what's the demand. In this case, it is given 1,60,000 units per annum, salary. Okay, and it is noted by D. And the basic assumptions of the model is the replacement is instantaneous. Instantaneous means what? At the moment you are placing the order, the materials or inventory will receive to your godown. There is no time gap. There is no time delay. You can say the technical term, the lead time is 0. So is it practical? It is practical, but it should be modified. That I am not going to discuss here. In that way, it is practical also. Okay. So replacement or receiving the material is instantaneous, and that's why you see this is the model. You suppose ordering Q quantity at this point, the amount Q units is receiving instantly. The consumption is uniform. That is also another assumption. So I'm not noting now, it will take time. That means consumption or use rate is constant. Uniformly it is being used, and finally it reaches to 0 inventory. At this point again, after say this is the time interval T, it is also required to be calculated in this problem that I will mention later. Here again another lot of Q. This is also Q. You are placing order with Q quantities. The same height is being taken and uniformly it is being used. Okay, and this is the shape of the model. It looks like an hacksaw blade. That's why sometimes it is also called hacksaw model. You should know that, because in exam, instead of EOQ model, it may be mentioned also through hacksaw model. Then actually this is the hacksaw model also. And before applying the formula, I want to show you here how the formula has come from. Basic knowledge only, not in detail. The detail is already done in my separate video that I have already mentioned it. So first, this is the given information. Ordering cost per order is 50 and carrying cost per unit of time. Unit of time means in this case per year is rupees 1. Now what is the total cost? Total cost for the inventory per annum. What is the total cost? That is, two types of cost are being considered. Two types of cost we are considering. One is ordering cost ordering cost, and another is carrying or holding cost, and writing carrying cost. Okay, carrying cost. These two type of cost are being considered here. Sir, why you are not taking the cost of materials? This question may raise to your mind. The reason is that these are the decision cost. It depends on the ordering size, but the material cost is fixed in this case, because say the demand is D and cost per unit of the material is C, then the total material cost will be DC, and it cannot change it. Both are constant, both are known, fixed. D demand is also known, cost per unit is also known. If discount is not all, that is a separate issue. That's why I am not taking here this material cost, as it is the deterministic cost. You have no choice, you have no decision to reduce it. You have to bear that cost, because demand is known, per unit cost. It is a very simple model, but it has very significant use in different models also. So another term of this is called the relevant cost. Relevant cost means which are relevant for decision making. The two types of cost are involved. Just I am discussing the basic idea, how the formula has come, and only then I will apply the formula to find out the economic order quantity. Okay. Now first, ordering cost. How this will come? D is the demand per annum. साल का demand D है, and suppose you are ordering Q units at a time. एक बार में you are ordering Q units. Then how many orders you have to place? D by Q. Suppose 1000 का demand होता है, 100 का order करते हैं तो how many orders? 1000 divided by 100, 10 times in this way. But D is the demand required quantity per annum, and Q are the ordering quantity per order. Because this is the number of orders. एक order का cost है CU. That's why this is the total ordering cost. This is the total number of orders per annum and multiplied per unit ordering cost. In this way, you can calculate it. Now, second, the carrying cost. How you calculate it? First, what is the on an average inventory? What is the average inventory? And the average inventory will be Q by 2. On an average, the inventory to your godown will be Q by 2. Sir, how this has come? That I am going to discuss here. First, I am noting what is the total carrying cost. This is the average inventory, and the carrying cost per unit of time is CH. That's why this is the total carrying cost. So why average inventory is this? When you are receiving the order, the total height of the inventory is Q, and the final it reaches to 0. That means, and the consumption is uniform. That's why the average inventory will be Q plus 0 initial plus final value divided by 2. Uniformly, it reaches to 0. That's why this is the average inventory. You can also find out in different way. This is the total inventory. This area of the triangle. What is the area of the triangle? We know area of the triangle is half into base. So this is the time period. Half into base into height. This is the total area of the inventory. Total inventory area. What is the average inventory? Per unit time average means on an average per unit time divided by T. Then again the same value Q by 2 will come. In this way you can get the average inventory Q by 2. And this is the carrying cost. So total cost, you can write R is the relevant cost is this. Now you have to minimize this with respect to Q. Means how much you will order at a time. That is the economic order quantity. So that the total cost will be minimum. This is the concept. Then how you can find out the minimum cost? There are two ways by which you can minimize this. I have shown in my separate video. Either applying the calculus method, the minimization method, you can find out the condition for the minimum cost at what Q, that can be find out, or graphical method also. I will give the link for that two methods also. I am not wasting my time here. And finally, after solving, then you will get the formula for EOQ. Economic order quantity will be this. EOQ, Q, this is optimum, that's why. For economic, it is written in this way. The formula will be this. 2DCO divided by CH. Where D is the demand, already I have mentioned. C is the ordering cost, and CH is the holding cost. So with the apply of this, you can find out the economic order quantity. I think it is clear. Now I am going to solve the given problem. Here D is given as 1,60,000, CO is 50, and CH is 1. Simply you put the value and then you will get the value of U. U order economic ordering quantity 1,60,000 into 50 divided by 1, and you will get the units 4,000. You can calculate and check. That means this is the economic order quantity. This is the best ordering quantity. If you order at a time 4,000 units throughout the year, then the total relevant cost for inventory will be minimum. Okay. Now I am adding 2 more questions here, 2 or 3 questions. The next questions you note down. The next question I am asking here, because with the help of this problem, you should understand other also, which can be given in your exam. How many orders has to be placed throughout the year? साल भर में कितना number of orders place करना पड़ेगा? That is one question. First, that I did. The next question, what is the time interval? एक order और एक order के बीच में कितना gap में order करना है? What is the time interval? That is another question that I will discuss how to solve it, and I will solve it. And the last question is, what will be the total relevant cost? 3 things you have to calculate. That is also a part of this question, which I have not written, but I am just telling you. So I have to use this space, that's why I am erasing it. Then what is the optimum ordering quantity or best ordering quantity? That is 4,000 units. Okay. So I am just erasing this part. So just you note down it. 4,000 units is the economic order quantity. Now, my first answer of the first question: how many orders are required to be placed during the year? In this case, say this is the number of orders required, and in the problem it is also given. One thing I have forgotten, that is, say consider 360 days in that year. 5 days are holidays or not producing, like that. Okay, 360 days. The first, how many orders? The total quantity required is 1,60,000 units. 1,60,000 units साल भर का requirement है. And the best ordering quantity I have already calculated, that is 4,000. एक बार में 4,000 करके ऑर्डर करना है. This is the best ordering quantity. सर आप कैसे बोल रहे हैं? तो ऑलरेडी इट इज कैलकुलेटेड द फॉर्मूला. यू कैन ट्राई ऑल्सो. 5,000 करके ऑर्डर करोगे तो फिर कॉस्ट बढ़ जाएगा. कम भी करोगे, 4,000 से नीचे चला जाएगा. 3,000 करके ऑर्डर करोगे, again the cost will be more. And this is the best ordering quantity. Then how many orders? That means 40 orders. 40 number of orders are required to be placed in that order. Okay. Now next question. This is second question. First is the EOQ, economic order quantity. This is the second question. How many number of orders are to be placed? That is 40 number of orders are to be placed for that year. My third question for R. What is the time interval? Time interval तो मतलब 2 ऑर्डर के बीच में कितना गैप होगा, टाइम गैप. एक बार ऑर्डर प्लेस कर दिए, दी इन्वेंट्री कंट्रोलर और द मैनेजर जो है इन्वेंट्री मैनेजमेंट का, वो आफ्टर दैट नंबर ऑफ डेज फिर सेकंड ऑर्डर, थर्ड ऑर्डर इस तरह से प्लेस करें. व्हाट इज द टाइम इंटरवल फॉर प्लेसिंग द ऑर्डर? तो साल भर का 360 प्रोडक्शन डेज ऑलरेडी आई हैव मेंशन्ड. It is given in the problem. You can also test 365 you take, and then slightly the value will be higher, but it is given 360 days in a year. And 40 बार ऑर्डर कर रहे हैं, 360 days जो प्रोडक्शन डे उसी का डिमांड इतना सब कुछ है. Then how many days? 9 days. That means the interval is 9 days. After every 9 days you have to place the order, and you have to place 40 numbers of orders. ठीक है, to get the entire materials. Now the last question. What is the last question? What is the total relevant cost? Again, I am mentioning the word relevant cost. Why it is relevant? As we are not considering the material cost, which is fixed here. You cannot change it. The demand is known, price is known. Price तो कम देगा नहीं, इसलिए वो तो कुछ करना नहीं है. But you can control the relevant cost. अगर 40,000 4,000 की जगह में 5,000 का ऑर्डर करोगे तो कॉस्ट बढ़ गया, relevant cost. अगर 3,000 करके करोगे, टाइम नहीं है इस मॉडल में, दैट्स व्हाई आई एम नॉट गोइंग टू शो, बट यू कैन चेक इट. नाउ टोटल कॉस्ट, टोटल हम लिख देते हैं. relevant cost for the year per annum कितना हो जाएगा? You put in this formula. So this is the formula. D given 1,60,000 and best ordering quantity 4,000. Already we have calculated it. Plus into CO ordering cost, that is 50, plus Q best ordering quantity 4,000 divided by 2 into 1. If you calculate, then you will get 2,000 plus 2,000, that is rupees 4,000 will be the minimum relevant cost per annum. This is per annum. Okay. Now, few special points I want to mention here. In the EOQ model, always the ordering quantity, ordering cost, and carrying cost will be same. If it is not that, then definitely you have made some mistake. You should check it. You see, this is the ordering cost and this is the carrying cost. This is same. If you have calculated this, say something else, say 2,500, and this is 1,000, that means something wrong you have done. So this is all about relating to this model and your given problem. So one more thing I want to discuss here. If I want to mention here, initially I told you this is instantaneous replacement. So what are the basic assumptions? If the model is come to your exam to present, then you will definitely mention the basic assumptions of the model, that is demand is known and consumption is uniform rate and the replacement is instantaneous. Then how it is practical, sir? If you place order at say any place, Salt Lake, and the material is coming from Slanet, still some time is required, but you are telling it is instantaneous. Is it practical? It is practical. How it is practical? As you know, the consumption rate which is uniform, the rate is, say the consumption rate or use rate is 20 units per day, if you know, and you know the lead time, say 5 days, 20 days per day is required, and the lead time is say 5 days. Lead time means the time interval between the placing the order and receiving the material. Then what you will do, you will place the order at the moment when 20 into 5, that is 100 units will be in your godown. Then what will happen? Party requirement is 20 units and 5 days is lead time. Within 5 days, this material will be vanished or finished. The inventory will reach the zero, and again you will place the order. Instantly your materials will come to your godown. That is the concept. In this way, you can apply the concept of instantaneous replacement. That means it is practical. But you have to place your order not at this point. You have to order at the point where the inventory will be in your hand, by which you can manage till the repetition of the order. I think it is clear. Now, another thing, sir, you are telling the cost per unit is fixed. But in practice, if you purchase more, buy more, then some reduction or some discount will be given. Then what you will do? That is a different model, inventory model, that is called discounted price EOQ model. I have also done in my separate video. You can check it. Slightly complicated in respect to this. Okay. In respect to this. Okay. So when the price discount will be given, then you have to apply that model. Another thing, in many problems you will see the carrying cost is given in percentage form. Say the carrying cost is 10% per annum. When the problem will be like that, then you will see that the cost per unit of the material will be given. Percentage means it is the percentage of the material. ये ध्यान रखना है. ये बोला नहीं रहेगा. It will be not written in the problem. When the percentage will be given as the carrying cost, then definitely the percentage of the material cost per unit. I think it is clear. So concept of discount I have already mentioned here, and carrying cost in percentage I have also discussed. These are the relevant points you should keep in your mind. Another thing, you always check. Sometimes in exam, what is given? The carrying cost is given per month and demand is given per year. Then what you have to do? You should not apply it directly in that case. You have to convert the carrying cost per month to per annum. Say the carrying cost per month is 50 paisa and demand is given per annum this. Then what we do first? First convert the carrying cost per annum 50 paisa per month multiplied by 12, that is 6 rupees per annum, and then proceed. Then you will get the correct result. The reverse can also be given. What reverse? Suppose the demand is given in month and carrying cost is given per annum. Then what will you do? You have to convert the demand to per annum. So both things should be in same unit, either month, either week, or per annum. Regarding ordering cost, no problem because it is ordering cost only. But in this case, you always check whether the two units, time units, are same or not. If it is in month, then both should be in month. If it is given in annum, divided by 12 to convert it to month and carrying cost in month, then you can proceed. So these are the special points to be kept in your mind. And this is your about your EOQ model. And for formation of the model, formulation of the problem, I have already mentioned. I'll give you the link and you check that video. So that is the entire thing of this problem. If you have any problem, you definitely mention to the comment box and I will give the answer at the earliest possible. अगर अच्छा लगे तो please put one like also and it will motivate to create more videos. Thank you all.